Hello everybody, welcome to our 20th meeting of Tribe of AI. Today we have a topic, Introduction to Reinforcement Learning. I hope that everybody managed to get access to the event. This is only our second online event, and I tried to make some improvements, but I noticed that some people couldn't find the link, so I just updated the information, and I would like to wait for just a couple of minutes, or maybe like a minute, for everybody to be able to join. Today we also have this ask a question at this link. So today, especially for today, we have like this reinforcement learning, and this is the topic which is like very interesting for discussion. I specifically haven't added a lot of hard material. This is not like I'm not here to retell you information from some source. I mostly try to point you in the right direction regarding this reinforcement learning, also my take on reinforcement learning and what I have found, what's important and what's interesting for me. So I think that I noticed that we have quite a few people already. So if anyone could help me out and try to ask a question at the slides.app.google, I would appreciate that very much, just to check if this thing is working. And as soon as that happens, we'll start. All right, so I think we can begin. First of all, before we start with the reinforcement learning part, as always, let me. I see that some people noticed that we have a problem with the questions. Let me try to fix it. Should be better now. We should be able to get questions for everybody, and we are ready to start. Yep, I get that some people don't have permissions, but I just fixed it just a second ago. So please give it a try one more time, and we can begin. So first of all, let me introduce myself. My name is Dovydas. Two main things which I do is I am the founder of Tribe of AI, and I'm also a machine learning team lead at Vinted. I like this machine learning and artificial intelligence is a thing which I do for quite a while now, and yeah, I noticed that some people are saying that it works now. That's amazing. And if you have if you want to talk about artificial intelligence, I'm probably a good person to refer to. I can point you in the right direction if you want to learn, or if you have just any questions regarding reinforcement, regarding just artificial intelligence or machine learning. These are our sponsors today. So Tech Consult, Vilnius Tech Park, and Vinted. Thank you guys, you're making this thing happen. So that's our plan for today. First, we'll start with the introduction to Tribe of AI. Then we'll move to the introduction to reinforcement learning. Finally, the last part is networking. I know I really tried to make the networking part happen, and I envision it for today that we are going to hang out in the question answering part of the app, like the top Ask Questions at Slides app Google. So usually this is, for me, one of the most interesting parts. After every meetup, we have like super amazing questions and really interesting discussions. I didn't want to lose this part just because of the quarantine and how is it in English? Never mind. So because we are pretty much cannot do physical meetings, and I want this still to happen. So let's try to make it happen in the question answering, like this part of the app. So let's start with the introduction. We in Tribe of AI have these three main things. We have meetups, Bootcamp, and Academy. And these are our most important products. So let's start with the meetups. The meetups is, so you are part of our already 20th meetup today. The meetups are gatherings of our community. Usually they have one or more presentations. I'm usually the speaker at these meetups. I try to provide a topic for for our month until the next meeting, and something which you can learn during this time until the next meeting. So the meetings are happening remotely because of the coronavirus threat, and they will continue. They will continue on site as soon as it's safe and as soon as these measures are over. Then we have a bootcamp. It's actually pretty recently finished. We have created this first 9-month long artificial intelligence bootcamp in Lithuania. 9 people have graduated, and we are already planning for the Bootcamp 2.0, which will start in September. So if you are interested, or it's very good time to start thinking about it and start maybe gathering information from the people who have graduated and stuff like that. Then we have the AI Academy. So if you were a part of our last meetup, we have rebranded what we previously called workshops. Now it's called Academy because it's right now much bigger in scope, and I try to put much more effort into this AI Academy. It's constantly, it's first of all moved to a new platform. It's constantly updated, and we finally have an S-class. So I envision a lot of great things for the AI Academy. So can't wait for it to get into full gear. The idea of the Academy is that you can learn artificial intelligence with no prerequisites. And this idea stems from our principles that we do not create any content. We also try to be practical. We try to aim to maximize your success rate. That means that we try to help you to succeed instead of trying to make it really hard or trying to make it too easy. My personal goal is to maximize the delta. So there you started before the Academy, and the level of your knowledge after the Academy. Finally, we try to use agile and lean principles because these principles are super important in practical machine learning, at work and in doing machine learning and artificial intelligence projects. So therefore, you're also using the same principles for learning. The AI Academy have various classes. Classes equals skill required for you to join the class. So for S-class, there are no requirements, and at the end of the S-class, you will have Python fundamentals. So the F class is for learning Python fundamentals. E class is for learning advanced Python. The S class is the first class for not learning, but for doing. So as I mentioned, we already have S class. Most of these people are bootcamp graduates, but not exclusively. And we try to come up with interesting AI projects for all of us to work on. And we already have some initial ideas, and some people are starting to collaborate already. Then we have a structure. You have to commit to more than 8 hours per week. We also meet every Saturday. You learn at home, and we sync at these Saturday meetings. The strengths of Tribe of AI is that we really try to embrace the social aspect. So I understand that everybody can learn at home. We actually provide all the information, all the learning material is open source, so you can go and do that on your own. However, you will be much like the probability of you succeeding if you embrace the social aspect is much higher. And we have like really amazing questions during the Saturday meetings. We have like we find pretty much a lot of good insights which were not like directly available in the course itself, but we come up with these insights as a group, or like us sharing practical aspects of which we learned at work, like especially regarding the artificial intelligence projects, or as more advanced deep learning techniques. These are very valuable to get this information, to get these insights from the community itself. Also, the tribe helps their members grow. So everybody, if you're part of the tribe, it's your job to help your fellow members grow. And you know that the others will try to do the same thing for you. Also, we have a new platform. So I just announced the platform last time. We are using the Mighty Networks platform. We have our website and registration. It's pretty much, if you just follow this link, you'll be able to register. Also, I'll post this link to Facebook, Meetup, and Slack. This will be a new place for our community, for teams, events, courses, etc. So I already see that we have one question. I'll move to the questions at the end of the presentation, but good job. Keep those questions coming. It will be like an excellent addition to the questions and answering session. As I mentioned, today's like this introduction to reinforcement learning is like 50% of the value lies in the types, in your questions, in the like you proactively interacting with this presentation, rather than me just telling you, oh, so you must watch these courses, read these books, and then you'll be adequate at reinforcement learning. So let's start. Introduction to reinforcement learning. This is a plan for today. First of all, we are going to talk about the key people in reinforcement learning. Then the applications, like theoretical applications or I guess experimental applications, and then practical applications of reinforcement learning. Then we'll discuss the key concepts of reinforcement learning. Finally, I created a list of the things which you must know to be good at reinforcement learning. And finally, the resources, so how to get started, how to get into this reinforcement learning like field or part of machine learning. So let's start with the key people. I've created this by the way, these people, they are not like absolutely smartest people in reinforcement learning. These are people whom I like personally, from whom I've learned something about reinforcement learning. and whom I would advise you to, I don't know, follow on Twitter or Facebook or whatever, like watch their like YouTube lessons, or like listen to their podcasts, and these are the people which I found interesting, mostly either via their courses or via their podcasts with Lex Friedman, or via their books. So these are like my main resources and my main people. So a quick introduction for everybody. So Demis Hassabis is the CEO and co-founder of DeepMind, so now part of Google. Like this, he's one of the like really key people in like the breakthroughs in reinforcement learning. Like, you know, things like there are lots of things coming from DeepMind, and things like which pretty much are driving the field forward. So therefore, I think Demis Hassabis is like probably like the number one person for me in like deep reinforcement learning. The next person is Richard Sutton. He's the author of Reinforcement Learning and Introduction. So probably the book on reinforcement learning. It's like super, it's not super easy, but it's super valuable. It serves like the definitive guide of reinforcement learning, especially the more classical reinforcement learning. We have a lot of, you know, like it's very hard to write a book for this field because the state of the art is pretty much moving forward every day. And even, you know, DeepMind, I remember the story when like Lee Sedol played with the initial, like, or I guess not initial, but like not final version of AlphaGo. And he was like, oh, I can beat this thing. Not too big of a problem. And then the machine, the algorithm made like tremendous progress. And even after like AlphaGo Lee, we've seen a lot of improvements in the AlphaGo, like in the AlphaGo model. Therefore, the state of the art, like it just shows how fast the state of the art is progressing. So Richard Sutton created, wrote this amazing book. I'll show the book in the resources at the end, but one of the key people involved, like pretty much you'll see him mentioned a lot of the time in various discussions or videos. Peter Norvig, he is director of research at Google. In general, one of the also key people in driving the reinforcement learning at Google. So like just added him for these reasons. Leslie Kaelbling, she's like very much a robotics person. She's also a professor of computer science and engineering at MIT. Also one of the like really interesting talk on Lex Friedman podcast with her about reinforcement learning. David Silver, he leads reinforcement learning research at DeepMind, so like second person from DeepMind. He's also I found him on the Lex Friedman podcast. Also, like later found that he has written a book. Also has pretty good like YouTube video lectures. So like very interesting person. Was quite like was really useful, like a really useful resource, a really interesting person to follow. Then we have Peter Abil. He's director of the Berkeley Robot Learning Lab. Also one of the key people in reinforcement learning. Then we have the last two people are Lex Friedman. By the way, he's not just because he has his podcast, but he himself is like a research scientist at MIT specializing in reinforcement learning. so one of like people to follow. Has a really good introductory lecture about reinforcement learning on YouTube. And finally, Ilyas Tutkever. He's a chief scientist and co-founder of OpenAI. So you probably know OpenAI 5. So these like this company is also very strong at reinforcement learning. Therefore, he is also on applications. So of course, the first thing which comes to mind is like video games or computer games. Naturally, this is the best environment for reinforcement learning, like applications to develop. Pretty much almost, okay, pretty much all of reinforcement learning breakthroughs are like managed through one type of game or another. There are poker playing computer games, there are like the Atari playing computer games, there is StarCraft playing AlphaStar, like reinforcement learning agents, and of course AlphaGo, so Go playing agent. But overall, this is the like the environment in which most of the reinforcement learning breakthroughs are happening. Then we have medicine. So again, this is experimental, but I read articles that reinforcement learning is already used to determine the treatment for health conditions and which drug therapies to use. So this is already being experimented in the medicine too. Robotics, it's like we had like initially, I guess, this notion that reinforcement learning will be great at robotics. Turned out that it's quite actually quite hard to transfer the knowledge from the simulated environments to the real world. So therefore, it's just also in the experimentation phase. I know that Boston Dynamics, probably the most famous robotics company, have acquired a startup. Don't remember the name actually, but a startup specializing in reinforcement learning. So famously, like Boston Dynamics didn't use any machine learning in their robots. However, seems that the field is not static. The things that used to be true can no longer be true, and it seems that we might see the next generation of Boston Dynamics robots that use reinforcement learning. Finally, industrial, or I guess not finally, even industrial automation. So these, there are some experiments being done in, I think, Shell, also in Google. They try to use reinforcement learning to improve the efficiency of their pretty much a lot of the systems. I don't remember exact applications, but Google manages their ventilation, and Shell manages their parts of manufacturing. So it's reinforcement learning is also applicable in this field. Finally, finance. Pretty much everybody wants to trade stock markets and various other markets with profit, and reinforcement learning promises that you can try to find statistical patterns, and if they exist, you can try to exploit them. It's pretty hard to do, and it's argued if anybody can do it, but it's also pretty interesting experimental application of reinforcement learning. Then we have practical applications. So as you see, not that many. Reinforcement learning is famously, especially deep reinforcement learning, is famously not yet very practical, but I guess we are coming to using deep reinforcement learning, especially in practical applications. It's just not clear which of experimental applications are going to be like truly successful in practical applications. Then we have key concepts. So the things which you must know that like to understand pretty much anything in reinforcement learning. The first thing is the agent. It is the thing, the like program, the like function, the class, the object which you are using to interact with the environment, the one which makes some actions, the thing that gets the rewards. It's like in most practical applications, the agent is the object which drives to solve the problem which you introduce for reinforcement learning in this reinforcement learning context. Then we have actions. So actions are the things which like the agent can do. And this is the way how the agent interacts with the environment. What actions the agent can take depends on the environment and also on the state in the environment. So it can be like if you have a computer game, you can like, you know, move forward, move back, move left, turn right, maybe, you know, like jump, stuff like that. Or it can be like something practical, such as like show the A test of the A/B test, like testing environment. One of the most important thing is that actions can be continuous or discrete. That means that you can, if you have like a computer game environment, it's discrete because you can only, you know, move forward by some amount, but you cannot move forward by, you know, 0.5327. So it's always a discrete action. But in, for example, in like robotic environment, you can take any action. For example, you can move your arm by an angle of like any arbitrary fraction of a number. So there are different models which support different types of actions. Then we have the environment. So environment is pretty much everything that's not an agent is an environment. The state of the environment is usually passed to the agent. So then next thing is the state. The state is that the thing in which environment is in. So you can have like an environment which is some like I'll show you later an example of a grid world environment, and I'll later show you the state. Like there are like hundreds or, you know, lots of different states in which the environment can be in, and the environment is at any one state at a time. But like this is the thing which the agent sees pass to it. It can be like some examples of the environment can be like pixels on a screen or coordinates of an agent, stuff like that. Finally, the reward. Reward is a scalar value that's obtained after every action. The environment provides the agent with the reward. Also, the reward can be positive, negative, or zero. You don't have to get just positive rewards or negative rewards. I know it sounds positive, but a lot of the time rewards are negative. The things which you must know for reinforcement learning. So first thing is the explore-exploit dilemma. So why it's a dilemma? Because every agent has to choose. Imagine if you're an agent and you know that, you know, going forward will like lead you to some, like, let's say good result, but you have never tried to go left, and maybe going left will, you know, just win the game or give you like super, I don't know, super reward. So as an agent, you must choose some part of the time to go exploring. And of course, if you only explore, you will never reach, or you just can reach your goal only accidentally. So the dilemma is like decision, how much time you should go exploring and how much time you should do the exploitation. So imagine there is a famous example about like playing these casino games. So imagine that the best the best slot machine to play with, but you have only tried 2 slot machines out of 10 in the casino. So you might not have found the best machine, you're just playing the best out of 2. On the other hand, if you spend all night just trying all the different machines and never playing the best one, you're also not going to get the best overall result. So this dilemma is about just maximizing your profits, minimizing your time spent on finding the best decision. It's the thing which every single reinforcement learning problem has to address in one way or another. Then we have Markov decision processes. So it's also a key concept in reinforcement learning. The reason why it is so important is because it allows us to assume, or we can if we hold this notion that the thing which we are dealing with is a Markov decision process, then we know that if we are at a certain state, it doesn't depend how we arrived to this state. As long as we are in this state, it doesn't matter what our previous actions were or what our previous states were. It's enough to model everything just knowing the current state of our environment. And this is the first order Markov decision process, where there are like second order, third order, stuff like that. But the first order says that only this current state is important. Everything that happened before is not important. This seemingly uninteresting and not super groundbreaking theory or constraint allows us to really to pretty much solve to be able to use the reinforcement learning models for solving these problems, because it simplifies a lot of assumptions. And you always, the first thing which you try to do with your reinforcement learning problem is you try to frame it in a way that it is a Markov decision process. Then finally we have Bellman optimality equation. So I haven't added the equation itself. In short, the most important thing about this equation is that you can model your rewards or your values of your action by using recursion. So your previous actions value depends on what happened, your next, I guess, actions value depends on what happened, what you're doing right now. So it's pretty much a recursive form how to write this thing. It also proves to be super valuable because you don't have you can with clever mathematical manipulation you can structure your your decisions in such a way that you know which action is the best for you. One final thing you have to know is OpenAI Gym. So this is the environment if you want to do anything practical with reinforcement, or I guess practical, anything hands-on with reinforcement learning. This is a must-have. This is thanks to people in OpenAI. They have provided us with this amazing environment to play, to test algorithms, to test our models, and it's pretty much what everybody uses to try their try anything new or learn reinforcement learning. So this is like very, very important from a practical standpoint. Then we have resources, but before we move forward to the resources, I want to show you the reinforce.js. So I haven't added, this is, by the way, this is by Andrei Karpati. I think at least the initial version was developed by him, and I haven't added him to the list because he seems to be good at so many things, especially making nice websites for teaching people. I promised to tell you about these environments. So this is your environment. This is your agent. Your agent will have to go to this cell. This cell has a reward of 1. This cell has a reward of -1, also -1, also -1. So your agent, the like goal of your agent is to find the best way how to go from here to this cell. Oh, sorry, to this cell, because this one has a positive reward. Find the best way and assign then for each action, in each of the cell, the agent is going to learn some kind of value. So let's see that in action. Let's go slow. So far, our agent, the agent learned that it's really bad to be in this state because it has C -1. Really bad to be here. Oh, it seems that the agent found the best way. So the best way is go here, 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 then avoid the -1 cells, and this is the path how to reach the best path how to reach the goal. Let's wouldn't be super interesting if we allow the agent to make this like have such an easy job to do this thing. So I'll stop it for a while. So these are the like Q values. You'll see this Q value concept. So these are the Q values of each cell. Let's this is the value of the cell. However, the cell reward is 0. So I'm going to make the reward minus, like really bad, -1. Not, I wanted to make it -5, but I'll use it later. So let's continue learning, and you see that the agent really quickly found another way. So now the agent uses this path to go here. So let's also have a reward of -2. So the agent will definitely not go here. Also, let's toggle the learning. Oh, it took the agent a while to find the new route, because this is pretty much blocked, right? This is -1, this is -2, so definitely let's not go here. And it took the agent a while to find the new best path, which is go down, 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 right, 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 up, left, and then up. Different like update algorithms or like reinforcement learning algorithms. You can also read more. As promised, we have Richard Sutton. As I said, it's like you have to read his book, because he's his book is so influential in this reinforcement learning circles, and even this website refers to the Sutton's book. It tells you about like temporal difference learning, about these Q values, stuff like that. And you can, like, what's really cool is that you can play around with various things in the browser. Also, the thing which I didn't mention is, remember, explore, exploit dilemma. So we have how much exploration you should do. So it's called epsilon, and how you can go fully exploit, or you can go fully explore. Let's see what happens if you go fully explore. You see your agent like tries a lot of different actions, doesn't regard to these minus cells, like gets a lot of minus rewards. However, it learns that the value of each cell like very good. If you go more for exploitation, so now the agent only chooses the best path always, so never chooses any yeah, at least until it converges, and sometimes the agent changes their minds. So this is like really cool resource which I wanted to show you. Let's go back to the final resources. First of all, I promised that a really cool lecture from Lex Friedman, this introduction to deep reinforcement learning, very much recommended. We also have a series of lectures from Stanford about reinforcement learning. So this is just this is the link to the first one, and I think we have, don't remember exactly how many, but we have like multiple lessons. We have a reinforcement learning course, full machine learning tutorial. So this one is by Free Coding Camp, like pretty nice course. Like it's very long, but one video lecture for everything. We have quite a nice two nice books. So the last one is by Sutton, so the guy from which I already mentioned you a couple of times, and the second to last is Foundations of Deep Reinforcement Learning. This is a more manageable book. The Sutton's book is like super huge, and this one is a little bit like, for me especially, it was a bit easier, not as like it covers everything, but in a bit of a like easier to grasp way, at least in my opinion. And these are the resources. Now it's time for me to go to the question answering session. I've noticed that we have quite a few questions already. So let's start with the first. Oh, you know what? Let's start with the questions which are the most popular. Hello, I have recently finished learning basics of Python's, data types, functions, object-oriented programming. What do you think would be the best next steps in learning towards learning machine learning and AI? And thank you very much for bringing AI enthusiast learners together. So this is the question. So thanks, Martinas. I think like we already have like pretty much everything structured for you in the Tribe of AI Academy. So I would say join our academy, like check out the resources, maybe join a learning group. I think we'll have this exact like a group which learns exactly these things in which you're interested in. So the next steps would be learning the basics, the fundamentals of data science, and then moving towards fundamentals of machine learning. And I think we'll start this team in a couple of weeks. So definitely keep an eye on the announcements. I'll probably announce the start during this week. Then we have Jonas' question: what should be done to avoid racism in reinforcement learnings with live data? Yeah, that's a tough one. Live data is always a tough problem. I think that like if you structure if you don't have like these omitted variables, so if you have a better explanatory variable, then your model shouldn't be racist. Usually if you just provide something that's that's predictive, but not the real variable which causes the thing, just happens to be correlated. For example, let's say you have I don't know, years of education, as a true predictory variable, but you do not include it. So your model tries to, like what machine learning models like are good at is using whatever they are given to arrive to the answers which are expected. And if you don't provide them with the true variable, with the true feature which determines the thing, then you are like the model will try to use something which like might definitely not be which you don't want to use skin color, or I don't know, gender. So one thing is like pretty much remove these variables if possible, or teach the model not to use these variables like by like the way training the model. If it's live data, I don't know, it's tough. It really depends on the problem, really depends on what you have available. So it should be like carefully considered. Then we have Audrey's question. Is it possible to create a system by learning AI and ML, which according to some kind of defined photos and description indicates what it is? From a camera is already searching for data online, or if the recognizer classifies. What level of programmer do you need to be? So it's like the classical deep learning program, the one which you will learn like in the introduction to deep learning. If you want something smarter, like for the model to like take into account the description, it gets a little bit tougher. But definitely what you cannot expect is that for a model which never seen this thing to be able to classify it. This is the like zero shot learning problem, which we don't have ways to solve yet. I mean, the industry or the field as deep learning doesn't know how to solve it. So assuming you are asking about this more simple problem, you would learn it in the B class introduction, or I guess deep learning fundamentals. We have a topic for discussion. Deep live reinforcement learning based apps, do's and don'ts. By live, you mean you launch the model somewhere remote and keep it running, feeding day by day the data, using user generated feedback. I think, yeah, let's after the official part ends, we can definitely have this topic. Let's see. We have one more question from Martinas. You already mentioned about AI being integrated experimentally in medicine. Do you think it will be integrated into clinical applications? And like the thing about medicine is if it saves lives, doesn't matter if your model has 96 or 97% accuracy or whatever. If it already can be used to save lives, like you should do it, even if it doesn't work like all the time, because you probably will have a lot of you don't want to automate something. You pretty much want something to end up with a better result. So I hope that they will be able to push it to production. The last question is, in one of the sessions of Tribe of AI, you gave good explanations about machine learning, deep learning, artificial intelligence. Can you connect reinforcement learning to that explanation and give it again? Yeah, thanks, Kevin. Machine learning, I guess let's start from artificial intelligence. This is the large old field. So remember that artificial intelligence systems can be hard-coded, and they're like the most popular artificial intelligence systems, and the ones which like people uninitiated usually think about are the ones which smart people and experts code their knowledge, pretty much these symbolic systems. and then like you code things like cats have 2 ears, cats have 4 legs, cats have a tail, and you code this knowledge to the agent, and then the agent can do some kind of inference. So for example, you tell the agent, oh, this animal has four legs, what type of animal can it be? And then the agent, searches its database and finds that, oh, it can be a cat or a dog. Like, just an example. So you don't need any machine learning for artificial intelligence. The best example, I guess, is the famous Deep Blue chess match against Garry Kasparov. They had this powerful computer which pretty much done like brute search, or I guess not brute search, I take that back. They had really clever tricks how to search effectively, but the machine didn't learn anything. It wasn't learning from the match, it wasn't learning before. Everything was pretty much programmed by the developers. Then we have machine learning, like pretty much much smaller part of artificial intelligence. So this is all about learning from data. So machine learning means that your agent or your program learns from the data. Deep learning means that your like model learns from the data, but it also has to use deep learning for that. And this deep learning is a small part of this machine learning. However, this is the part which is most interesting right now, because it allows our models to understand like real world or unstructured data, such as images, videos, sound, natural language, stuff like that. So it wasn't previously possible to do these things. Now these deep neural networks allows us to do this thing. And can I connect reinforcement learning to that? So reinforcement learning is part of the machine learning because it learns from the data. Like, look, if you see this, our agent is still learning. So our agent gets some reward and it updates its knowledge. So since the data can change, and you've seen that I've changed my values, and the agent learned to avoid these paths and chose new paths. So that means that the model is constantly like learning from the environment, therefore machine learning. We also have deep reinforcement learning. So deep reinforcement learning is actually, in practice, is so much trickier to actually make it working. So like I would definitely suggest starting with the like classical reinforcement learning, but then again, deep reinforcement learning can be super powerful, because you can store, instead of storing all of these values inside some kind of matrix. Imagine if you have like millions of times more values. It will be pretty much impossible to store them somewhere. So this deep network allows you to store these values in a much more efficient way, and provides you with the best guess. So for example, if right here in this cell your best course of action is to move down, and you have like billions and billions and billions of these like options, so deep neural networks allows you to choose these actions with much more space efficient way. That's what I wanted to say. So deep reinforcement learning, very exciting thing, even trickier to get working. Let's see, do we have any more questions? I think that we don't. So it's really cool to have our already second session, second meetup online. I hope that it was useful. I hope it will give you some good starting point towards reinforcement learning. And see you again next month. The date of our next meetup is already announced. We are going to talk about, so if we haven't talked about the most practically applicable thing today, so reinforcement learning not super practically applicable. So the next time we are going to talk about tabular data, and this is very, very much practically applicable. So see you next time. Thank you all for participation. I'll stay around in the Q&A section to answer more questions. And thank you all. Bye-bye.